Hello friends, I am Kushal Sen, a professor in the Department of Textile Technology, IIT Delhi, and with you I shall be discussing some important issues and topic on inkjet textile printing. I believe in the other modules that you have gone through, you would have probably discussed developments taking place in the polymers and fibers, in the manufacture of yarn, the various types of yarns which are in advanced level manufacturing. Similarly, advanced fabric manufacturing, you must have been discussing with other colleagues. In this module, we will concentrate on one of the very important unit operations in the wet processing of textiles, which is called printing, right. Specifically, we will be talking about inkjet printing. So, let us hope you enjoy this session. We like to first understand the basics and fundamentals, and so we do a bit of revision of what printing is and how the digital printing has become more important these days, and how is it going to progress and why is it going to progress. These are the things which we may like to discuss. So, first just let me introduce some of the things that we are going to discuss. So, we will talk about the basic digital printing, inkjet printing in specific, principles of drop formation, typical machines for printing of textiles and the current status, the various types of inks, the challenges that we have, and some discussion on pre and post treatment. So, people may like to understand sometimes the people who know little less about, let us say, the textile, talk about printing as an art. Some of us say no, it is science, and let me tell you, most of the business people would be interested in textile printing because it actually gives them a lot of money. All right. So, let us see as we progress what the printing is about. So, let me just make a simple statement, and that is printing is one of the most difficult unit operations in the wet chemical processing sequence. And what do we mean by that? What we mean is that you cannot afford to make errors in printing process, because if you make errors, the people who can point out your errors could be novices. So, remember, if novices, people who hardly know about printing, who hardly know about textile processing, can tell an error, a printing mistake, then it becomes more difficult. In various other operations, for example, you have finishing operation where you have wash and wear finish which has been given to the textile fabric. It will be very difficult for a novice to find out the mistakes, errors in finishing process. You will require some experts, you will require an elaborate testing procedure before you can point out, well, there are errors. In printing, you do not need that. So, what it means is you got to be right the first time. There is no second time. When you do the dyeing, for example, if suppose the shade is less than the desired shade, you can top it up. If it is more than that, you can strip it up. So, some corrections can be made in dyeing processes, but in printing there is no reprinting. Once it is printed, it is over, you got to be right the first time. Therefore, it is one of the difficult operations, and that is the reason the people who actually are in charge of printing, sometimes they are known as printing masters, they probably get the higher salary. But a businessman who has a print house gets the maximum advantage in terms of money, because printing obviously adds a lot of value to the product, right. So, I make this statement. Just to revise, I am sure some of you would already be familiar with this, the styles of printing, what it is. There are three basic styles which classically people have been talking about. One is called a direct printing style. That means you have a fabric which could be white or colored, and you have some design, and you print the whole thing on a fabric directly, and that is called a direct style. Other style which is an important, interesting style, little more complex of course, is a discharge style, where generally the fabric is dyed first and the colors are removed from the portions where we want the design to appear. Now, complex again, it could be a color discharge or a white discharge. So, you have a colored fabric and then you remove color, that is the discharge process, and that is the discharge style. Resist is another style where you chemically or mechanically block the areas of the design, so that if you put the die on the top, it would not go there, and therefore, design would create. So, these are the three basic styles of printing. Of course, direct is the most popular one, simple one, and is as effective, but sometimes we may have to resort to a style which is discharged, which would give you more pleasing effects, or resist, which will be very unique in its own sense. Then another term that is defined is called the methods of printing, different than the styles. So, what do we mean by method? Method is how you apply the color to the design area. So, you may have probably been already told sometimes in some classes that you have a method which is called the block printing method, and where you have wooden blocks or any other type of blocks which are put on the print pad, and then you put the design on the fabric. The other is a roller printing method, where the design is engraved on a metallic roller and the color is continuously picked up, which we sometimes call the paste, printing paste. It is picked up from the rollers and it is stored in some sense temporarily in the engraved design, and then as the fabric presses along it, along the movement of the machine, and the design or the color get transferred from the engraved portion of the roller to the fabric. And the most popular of all of them, as far as the industry is concerned, is the screen printing method, where you have a screen, could be a fabric screen or a metallic screen, where some of the areas where you do not want the colors have been blocked by a polymer and the design is exposed. And then what you do? You take a squeegee, put the paste, and the paste is transferred onto the fabric. It could be a flat screen, so we call it a flat bed, or it could be a rotary screen, which where the screen is cylindrical and the paste from inside to outside moves with the help of a squeegee continuously. So, rotary screen printing is a continuous method of printing, roller printing method is a continuous method, while the block obviously is not so continuous. Similarly, flatbed is also intermittent process, whereas semi-continuous process it can be termed as. What else as far as the methods are concerned? Today we have other methods. One of them is called transfer printing, and what we will be now talking also about is the inkjet. So, we will be concentrating on the inkjet in this module on printing. So, a conventional printing method, right. So, it could be block or it could be screen or roller. What does it involve? Obviously, somebody has to approve a design. This design may have more than one color. So, you do color separation, where the green is going, where the yellow is going, all that has to be separated. If it is screen, the number of screen will be equal to the number of colors. The design has to be transferred onto the screen. The color, the printing paste has to be made, and once you have the paste, then you apply through the screen or through the roller onto the textile different colors. If you have 5 color designs, you got to be 5 screens or 5 rollers, and after that you have done the printing, that has to be dried. Then after drying you have to do fixation. After fixation you will have to do washing and then drying, and that is how a conventional printing method works. The transfer printing that we talked about as a method, as it says transfer. So, print is first put, or the design is first printed on a paper or any other medium, and then at a later stage it is transferred onto the textile. Now, that is the transfer printing. So, it is clearly different from the other methods. You can say, well, complete printing has taken place on a paper, but on textile it is being transferred from a paper or any other medium which is used for transferring. So, that is what it is, right. So, paper is, let us say, is printed first and then you transfer on a textile. Why do we do that when you can simply directly print? Well, one of the important thing is the surface of a textile is much rougher, the paper is much smoother, and therefore, fine lines, beautiful, the design aspects, the color resolution, all of that can happen much better in a paper, and then once you have done a good job, you can also then transfer the same thing, which would mean everything is going to be carried. Paper, for example, is a much more rigid dimensionally compared to a fabric, although we do work hard to make sure there are no shifts in this whole process, and so design should fall where it is supposed to, but it is much easier on a paper for various reasons. Therefore, you can go for a transfer printing. Maybe you know which fiber and dye combinations can be used. I am sure you have some idea. For example, for polyester fiber or fabrics and dispersed dye combination is the most popular transfer printing method, and this itself therefore becomes a limitation, because then you are not talking about dispersed dye and polyester. So, when you want to talk about transfer printing of acid dye on nylon or reactive dye on cotton, you may not be able to do it, or for that matter pigment printing. So, while transfer printing by itself is a very interesting method which can transfer exactly what is printed on paper. You have seen various kinds of photographs, sceneries on the paper, all that can be transferred as it is on the textile, and therefore, it is still an interesting method and technology. So, just for information, the transfer printing paper also today can be printed by inkjet printing. So, paper itself can be printed by inkjet printing and then transferred. Otherwise, there are other methods which are there, which can be used, like the flexography, the gravura, the lithography. These are the classical methods of paper printing, and so these of course you can use and then later transfer to the textile. So, these are various methods which can be used. Where do we go from here? Now, we say our method, which we are going to be spending some additional more time discussing, is called digital printing in general. So, you had various other methods like the block, the roller, the screen, the transfer, and now digital. So, we will be spending more time on digital printing. Why go for digital printing? One is the whole process of sending information. The systems have become more global. I can communicate immediately and say, well, this is the design I want to print, and the printer may be somewhere, let us say 1000 miles away from me. So, if you have a digital information, it can immediately be communicated to the person who can print. That is one. Other is a quick response. So, if I want that something to be printed, let us say just now, there is no other method other than the digital which can do this. You want to print your photograph on your T-shirt, digital method is the one which can do it almost immediately. Of course, when you are going for commercial printing processes where thousands of meters of a certain design has to be printed, well, then you are talking about industry. In any case, response is very quick. Other is an ecological considerations. So, today environment is one of the most important considerations every time you do any kind of a processing, polymer, fiber, dye, any wet processing. People will talk about what is the effect of your process on environment. So, waste minimization, reduced pollution, all those things are going to be talked about. Digital printing can actually help you do that. There was a time when we always said the cost of production comes down when you do mass production. Of course, that is true. But today also is an era of mass customization. Normally, in conventional printing, if you want to put any beautiful design, then you would like 1000 meters, 10,000 meters to be printed. Digital technology can ensure that mass customization can take place. That means, theoretically each and every individual customer can have its own design, which may be different from any other design that exists. That is therefore very important. So, you have a motivation to go for digital. Shorter runs. With time, people say, well, I am interested in only, let us say 50 meters to be printed. A roller printing industry would say can't do it, not economical. Similarly, screen printing, people also will not be interested in very short runs. But today, because of the flexibility people want to have, they are interested in a very small meterage, yardage to be printed, shorter runs. And the special thing about this is you can actually do photographic image printing, which definitely is not possible by block roller or screen, because as we said, the number of colors in the design is equal to the number of screens or number of rollers or number of blocks. If that is true, then you can't print a face. You look at a face starting from this to this to this, the shade keeps changing minutely, but it does change. Now, if you look at the number of shades actually in any photograph, natural or of a person, they are tremendous. And if you really want to use older technologies, then you probably have to create umpteen number of screens, which will be very, very costly process. So, digital technology allows you to go for a printing which is photographic in nature. Now, we are talking about textile printing, a laser or an inkjet. You are quite sure for paper printing, laser technology is as much advanced. Inkjet also is used for paper printing. For textiles, on the other hand, till today, we are only have inkjet printing as the method and technology available for printing. And therefore, our further discussion will be on the inkjet. Laser technology is not available for textile till now. Now, how could you print a photograph? You can print a photographs, get millions of shade theoretically and also in practice with just 4 colors. When you say if you had a conventional printing, 5 color design meant 5 rollers or 5 screens, millions shades cannot be produced by that method. But here, just using 4 colors, cyan, yellow, magenta and K is black, CYMK, right. Now, if CYMK, that is the 4 colors are used, you can actually obtain photographic prints. How is it possible? We will discuss this. So, before that, let us talk about how the conventional printing was done. In a conventional printing, let us say you have 7 colors or 8 colors, then people prepare paste, match the shade, add little more, maybe combination of more than one dye, and then make a paste which would appear to be similar to what is the requirement. All right. So, you prepare a shade, a paste with a required shade, which can give a required shade. All right. Those things are called spot colors. It is a very skilled job. So, the conventional printing uses spot colors. So, wherever you put a color that has already been sort of mixed properly and you got color. Therefore, number of shades is equal to the number of screens, is number of printing stations. Now, that is the spot colors. Other colors which are called process colors are different. For example, the inkjet printing process uses colors which are not mixed before. Let us say we said 4 colors, they are 4 colors, they stay separate, do not mix them. The desired shade is obtained on the fabric during printing. So, these are called process colors. Now, what it is? Have you seen a printed paper under a microscope or a lens? what you will see is, from the normal eye, it looks a nice beautiful color. If you enlarge it, you may see there are small dots there positioned at different areas. Based on the number of dots, the color of the dots, you may get a perception of a certain type of a shade. So, only 4 colors spread around in different areas can give you a perception that this is a yellow or a reddish yellow or a greenish yellow or a bluish yellow. All those type of shades can be seen, observed, perceived. Why is that? Because our eye, which is one of the best sensors that you have in the world, has only 4 types of sensors which measure, which perceive color. So, you have rods and cones, right? If you want to learn more about it, of course, you will learn more about the eye. But important thing is, cones can distinguish between 3 colors which are standard. For example, if you look at the spectrum here, you can say that you have 3 types of cones. One of them is called the red, called the green, and a blue. These are cones, all right. This is for a rod. The rods generally perceive colors in this range which are grayish, blackish, and so forth. That means we have 4 sensors, but we see everything. And how does happen? The integration happens in our brain. So, all this information which comes gets integrated in our brain, and we get millions of shades, millions of colors, and I can perceive it. This inspiration has come from here, and so digital printing or inkjet printing uses therefore 4 colors and can create millions of shades. Therefore, you can actually get a photographic impression. How is it done? It is like pixels on your display screens. In a textile, for that matter, is the same kind of thing that will happen. So, we have tones. A number of tones can be equal to the resolution that you create versus the colors that you have. So, n square plus k plus 1. Let us say, for example, I have only one area where I can put some color. So, the matrix is 1:1 multiplied by 1 color plus 1. This gives you 2 possibilities, either there is a color or there is no color, all right. But if you have a 2 by 2 matrix, then suddenly you have possibility of no color, some color, some more depth and fully covered. So, theoretically 2 square, 1 color, 2 into 1, all right. So, five. So, you have 5 possible combinations. So, you can get, suppose you have in the same 2 by 2 matrix 2 colors, then what you get? You get 9 possibilities. So, what you are doing is, you are not mixing colors, but putting dots in areas defined, and you get different shades. The eye will perceive differently. Now, the whole thing is, if your dots are very large, then they will be perceived as separate entities. But if resolution is high, dot size is smaller, so small that by eye you cannot distinguish that there are 2 dots or 5 dots. The image gets merged and you get different shades. For example, if you have a 4 by 4 matrix and only one possible color, then you can get 17 different shades. If you have 3 colors, let us say C, Y, M, then you can get so many shades by permutation combination. An 8 by 8 matrix, you are getting into this number, and if you have 16 by 16, which normally may be there, today we are talking about much more than this, then you are looking at millions of possible shade. What is the advantage? Obviously, photographic image, because any photograph that you see has got many shades, and all that can be picked up, converted into digital information. The dots can be put the right place, and then you get millions of shades. So in general, what will be the concept? Concept will be separate the color. Of course, you have to separate, but any design will be separated into 4 colors. Let us say minimum C, Y, M, K. Right? C is cyan, yellow, magenta, K is black. Right? 4 color printing. The print head, so there is a print head which delivers each color in a dot formed accurately to desired place. This is what is done. The size of the drop can be controlled. If done accurately, can produce million shades, and so you get photographic images. Right? That is how this technology is the highest advanced in that sense. So, in a nutshell, if you just say that what you require is of course a design, what you require is some computer where digital information either through scanning or camera or whichever device that you have, and then transfer the data onto the inkjet printer with a software which can obviously do the separation, obviously give right information, and should be able to eject the dot, put the dot at the right place. So, eject the drop and the dot is created on a surface, which is a, let us say, could be a paper, could be plastic, and we are talking about textile. But remember, this is a non-contact printing. What are we talking about? Inkjet printing, digital, non-contact. So, if you had block, it would contact the fabric. If it is roller, it contacts the fabric. If it is screen, it contacts the fabric. Even if it is a transfer, it contacts the fabric. Inkjet printing, the printing head does not touch the fabric. So, looks simple, right? So, in a nutshell, this is how I am introducing the subject. So, you have to create small droplets of ink from nozzle. The droplets can be of different colors, different could be 3 or 4 colors. The droplet must be positioned by some digital signals. The drop formation involves some way to apply pressure so that the drop can be ejected, and the ink which is ejected must be in small droplet forms. It could may be converted further to smaller droplets and directed to right places. This is our inkjet technology. So, when we talk about droplet size or a volume, what we are looking at could be the order of 3 picoliters, all right, being thrown out of the nozzle, maybe at the point where it is just coming out of velocity which may be as high as 40 meters per second. Excitation frequencies are very high and could be as high as, in some cases, megahertz. Now, do you think it is an art? Definitely not. In fact, this technology suddenly gets out of the domain of the conventional textile printing specialist, and it goes into domains of more technology. Who are the type of people who are in the business? Not the typical machinery manufacturers, typical textile machinery manufacturers. No, now you have something called Epson. You remember Epson? Paper printing systems. HP, Seco. Did you hear them before? Any printing systems? No. These are the guys who understand the electronics and the jets, ink jets, and therefore they are now in the business of textiles as well. Big names are also coming, DuPont. So, why big names? Simply because now you can earn money. Earn more money, more big people will be there. Now, let us look at a little holistic view of this whole technology. It has been more or less said in a much more convincing way that generally about 10% less color would be consumed in this process, because you only add what you require. We require color of a green, you add green, you do not need anything else, and so less color. Water consumption is reduced. A rotary screen printing consumes water close to 50 to 60 liters per meter. You have to do paste, you have to do washing, you have to do drying, and again wash, and many times you wash. All that is required too much. But a report which have been published talks about that inkjet printing can save water. Some values have been put up saying almost 40 billion liters of water worldwide was saved because of this in 2018. Well, this is one of the data, but more important is that you are now becoming more green. Then we talk about whether interest is growing or not. Some studies talked about the forecast about 17.5% growth. The market value could be in something like 2.66 billion. So, looks like there is business, but still this business is still tiny. It is a tiny business, small business. Just about 2.8% of the overall printing market is what the inkjet printing currently is holding, but as we grow, this share may keep changing. and one of the reasons was the cost. So, as the progress is made, the cost become competitive, you will see the growth of inkjet printing much faster than what has been predicted also. So, shall we say exciting times are here nevertheless. From here let us move on. So, we now understand that it is a very exciting technology which can change the face of printing textiles. Now, how do we print? So, we talk little bit about them. So, we just spend a few minutes on piezoelectric actuators. Now, actuator is something which obviously gets actuated. Displacement can be one of the outputs by pushing or subjecting it to some potential difference. So, piezoelectricity became a very important thing, and this is really more responsible for the technology being developed for inkjet printing. So, historically the Carolus and Franz reported that some electrical charges could be generated when temperature of certain types of crystals and ceramics would change. That is one, that you change the temperature, you say, well, there is some electricity getting generated first. Then the Pierre Curie and Jacques Curie also were the ones who found that if you apply polarity of different voltages or you do any compression, then some voltages could be generated. So, this is the stress can generate voltage, or reverse of it, apply voltage, the dimension of those crystals can change. This is what was interesting observation. This type of an effect, Hankel called it as the piezoelectric effect. Now, why I am talking about this is these are important materials, engineering materials for us. One of the interesting materials in this series are the ferroelectric materials. These materials exhibit one or more phases and have polarizable domains in their structure. So, you apply voltages. So, polar entities could orient themselves in the direction of the applied voltage, and this polarization can be changed also by changing the applied electric field. This class of material, which is the ferroelectric piezoelectric material, is a very important class of engineering materials today. There is a process called poling. The dipoles which are there in these entities, the crystals that we are talking about, they are generally randomly oriented, and because of that you do not see any effect of compression or extension, but they can be polarized. The entities therefore can take up change their position to match a certain direction. So, this is called poling. For example, if you have piezoelectric material which is not been subjected to poling, would have these entities arranged in a random manner, but when you apply a electric field, one may find that they start getting oriented. Once you orient them, they become very interesting material. So, some examples, for example, quartz, barium titanate, and one of the very interesting materials called the PZT, lead zirconium titanate. and the figures on this side show a displacement D, that is displacement picometers per unit volt, all right. So, this you apply certain voltage, there will be this piezoelectric constant D, that means dimensional change, very small, picometer very small. Barium titanate has more, PZT has still more, but it becomes important to us. So, by looking at this table, you can say that the level of strain generated is not so large, but is good enough to be exploited in engineering applications. So, essentially a piezoelectric crystal can be used as a displacement tool by impressing suitable voltages, right. So, impress certain voltage, there will be some displacement. The transducer could be attached, this piezoelectric transducer could be attached to a membrane that forms or is attached to the chamber wall, or it may itself act like a chamber wall. So, when you apply an electric field, the chamber volume is proportionally reduced and drop is ejected. Therefore, for all the inkjet printing systems, the piezoelectric transducers will be part of this assembly, which complex assembly, which we call as the print head. Before we go for print head and machines, let us look at the principles of drop generation in inkjet printing systems. So, basically there are two types of principles that are used in design of the print head. One is called the continuous inkjet process, where the jet of the ink or the droplets of the ink are continuously being jetted out of the from the head. Other is a principle called the drop on demand, that a drop is generated on demand, mean wherever there is a design requirement that the yellow drop must come, the yellow will come, otherwise it is, let us say, dormant, all right. So, continuous means drops will continuously keep falling, and drop on demand means drop will be generated, ejected only when required. So, these are two principles, and there are machinery manufacturers who are using both these principles to make inkjet printing. So, let us look at what the continuous inkjet principle is. So, one of the principle is called the binary process. Binary process. How is binary? It is binary in the sense that you have this reservoir, ink reservoir. The ink can go in here. There may be these transducers on this side. They push, let us say in this way they push. Once they push, the drop will come out. Then there are charging systems. Some of the charging systems will be able to make the drop size smaller. Other will be deflection systems, which can either let the drop go straight to the textile substrate. If it is not required, it will be deflected to a drain or a gutter. So, There is a transducer obviously here, which is the piezoelectric based transducer, which can squeeze, but continuously it will keep squeezing at a certain frequency and the drops will be ejected. The size of the drop can be further reduced by applying charging systems and then deflected wherever not required, the drop goes to the gutter, wherever when required then it falls straight. This is a binary process. So, either on the fabric or not on the fabric, that is the binary part of it. So, important thing is the drops are produced continuously, can either fall on textile fabric or are deflected. Applied electric field can charge as also deflect. The jet velocity and the frequency of excitation determines the drop size, which can be controlled to very high accuracy. Now, this is all electronics now for you, but material science also. So, you have a piezoelectric material, then you have a ink which has to be handled, then you have a ink drop which is to be charged and size could be controlled by the voltages that you apply. So, you have a piezoelectric system in combination with a charging device for jetting of the ink for charging the droplets. Continuous jet with drop size varying from 3 to 40 picoliters can be generated. Role of a drop volume, if 3 to 40. If you want small drops, means small dots, so resolutions could be good. Okay. Now, the question is that textile is one material other than a paper which has been printed, that it has to be washed, right. You have to wear it and go away outside, and therefore, certain amount of penetration is desirable for fastness properties, particularly wash fastness, rubbing fastness, dry rubbing, wet rubbing. So, you may require more volume of the ink. Now, remember in the conventional printing we called the colored material as a paste because high viscosity. Here we are calling it as ink, which is low viscosity. Obviously, we are dealing with volumes which are very small volumes. We probably cannot afford to have very high viscosity because everything around this ink chamber is delicate. It gives little pressure to remove the drop, but it can't give pressure if the viscosity is very high. You would have damage being done to the whole setup, the transducer and all the electronic systems. So, if very small drops are there, resolutions will be very high, can be high, or larger volume can have little more penetration, fastness properties could be high. What can charging do? Charge obviously can be used as for deflection purposes, but charge a drop, it can disintegrate, so that because there are same charges everywhere, they in a way do not like to be together. Suddenly you find if you charge a drop, it fragments. So, you can make smaller drops also. So, this thing can also be done. Then there are in continuous inkjet system, you have multiple deflection systems, which is different. Different in what sense? That the drop that goes straight actually goes to the gutter, and you have deflection systems which can deflect more or less. That means, you can put the drop at different places based on the signal that you have, right. So, that means continuously the drops are coming, and anything you do not want straight goes the gutter. What you want obviously can be deflected to two different areas. So, what is the advantage? Advantage is of the multiple deflection that you would be able to get more area printed. Any disadvantage that you can think of? Any disadvantage? Well, one other thing which you can probably see is that the circularity of the drop may get changed. It may become elliptical as it moves out, you can probably understand. Also, the one which is going farther away would have to traverse more distance compared to the one which has to go less, and therefore, the minor and the major axes may not be same. That is one disadvantage of this multiple deflection system. When there are in continuous inkjet system called pulsating system, high frequency, very high frequency pulses are there, and then you get very small drops. So, very high frequencies they work, and then you can get very small drops, velocities are also high, and so better resolutions could be obtained. As I said, the frequencies could be as high as 1 megahertz, and because the frequency is high, therefore, the deflections are smaller, and so smaller droplets get generated, and that is very interesting. So, this is just some of the principles which people have been using to create droplets, finally, which will become a dot on the textile substrate. The other principle is we call it drop on demand. So, there is no continuous ejection of drops. They say when the drop is required, the drop is generated, and so there is no question of deflecting them anywhere, they go straight to the substrate, and so the circularity will be maintained. The distance will be the minimum because it is coming straight from the nozzle to the surface of the substrate, and so your frequency required, or on an average the frequency requirement also are less. So, here also the piezoelectric crystals can be used for displacement as a tool, as we said there also. The frequency input can be obviously related to production. If you keep pushing them faster, more drops are going to go, because nothing is going to the gutter. Yeah. So, directly frequency can be related to the production also. So, one of the configurations, there are many configurations people have been using. One of the configuration is the crystal on the top of the chamber. Remember, the chambers are also going to be very small. They are not very large chambers, but they are still called chambers. So, you have the crystal on the top, the piezoelectric crystal on the top. Sometimes this is also known as a shear mode. All right. So, why this? Here the electric field is applied perpendicular to the poling direction. So, the shear takes place. Drop is generated when needed, that is what the thing, and there is no drain here, right. So, this is what you remember, directly onto the textile. A squeeze mode is the one where the crystal may be on both sides, and you squeeze the chamber, and then the drop will be ejected. There is an interesting thing on the drop on demand also, was called thermal inkjet, which is not using the piezoelectric crystal, but using a thermal system to create a drop. So, what you have here is a heater somewhere there. This heater quickly generates a bubble. Why? Let us say you have an aqueous system, aqueous ink. So, you heat, a bubble, a steam is generated, localized steam. How much? Look at this. Quickly the temperature around the same small little heater can rise to as high as 300 degrees centigrade. Around that area the pressures could be generated which could be as high as 70 atmosphere. So, what it means is immediately the drop will be generated and ejected out. So, if you put this heater on the top, it is called a top shooter. So, it is shooting, but interesting, right, but very small, localized, very quick. So, interesting points you may like to understand is, so there we discussed at the moment only two types, there can be more types also. The thermal, which is creating the bubble and ejecting the ink, and the piezo. The thermal is more displacement takes place. The size of the sensor for a piezo has to be larger compared to a thermal which could be smaller. So, what it means is more number of chambers can be created in a given area for a similar amount of displacement. For example, here somebody talked about that you want 30 picoliter to come out. So, the sensor area should be so much, because the displacement let us say is 0.1 micrometer. If it is thermal, then you may probably require much less area, that means more compact packing of nozzles could be there. Solvent ink, pigment, phase change inks, etc. There can be little different systems, they are different systems. So, the piezoelectric systems are more suitable. By changing the voltages and similarly by changing the available dimensional change, one can do the drop control also. So, in some sense one can say a fabrication of a thermal jet is easy, less complex, but the trapped bubbles, they are there, they can cause some problems, because the air which is dissolved in the ink can also at the rough surfaces of the chamber can cause various bubbles. So, they are the nucleating systems areas. They can absorb the created pressure by the heater, and so partially modifying the pressure pulse which was designed as the design pulse pressure was something else, and you have this air bubble somewhere which can modify this, and if that happens then you may get different volume than expected. This can happen. But is thermal inkjet better? If somebody wants to know, well, this question has to be answered not in this way, but if you want to use pigment based inks which normally may have to binder in their composition, then you may not like to use thermal inkjet system, because this increase in temperature can help or to polymerize the binder, and so the nozzles can get choked, viscosities can change, and so on and so forth. But otherwise, yes, it is good. The inkjet, continuous inkjet systems, because of deflection systems to be there, positive pressures have to be created, ink recirculation have to be done, the print head are generally more costly. Although in smaller areas more chambers can be fixed, but overall it becomes a little costly. And so, another important thing is that the operating frequencies of these devices, which are the continuous inkjet printing devices, are much higher. Okay. They are much higher than the drop on demand systems. So, we may just say in a nutshell that in the case of a CIJ, which is continuous inkjet, the drop generation is simple, manipulation of trajectory is complex. On the other hand, the DOD, the drop generation is little complex or as complex, but there is no trajectory manipulation. Why the drop generation is little complex? Because you want to generate when you require based on the design. So, the software and the hardware must interact properly. So, in a CIJ, the drop generation is simple because you have the same frequency, keep generating the drops, and then manipulate where it falls. While in the DOD, drop generation is a little complex because you need drop only when you need, but no trajectory manipulation because it has directly fall. In general, people believe that the TIJ, which is the thermal inkjet systems, can have deposits on the heater surfaces, therefore, the conductivity may be changed, and so how much displacement and temperature rise will be there may change with time. Corrosion of heater surface can also take place, and the bubble formation and collapse is basically a violent process, very, very high. So, that is something. Therefore, the life of this thermal inkjet print head system is going to be less compared to a piezoelectric inkjet system, which is more robust, to say that. So, what have we learned in this module till now? We have learned the basics of inkjet printing and also appreciated that how photographic images can be printed by inkjet technology, which cannot be done by the other conventional systems. What are the general principles of the continuous inkjet? What are the principles of the drop on demand? And some advantage and limitation thereof is this what we have done till now. In the next session that we will have, we shall discuss machines and the inks, right. We do not call them pastes, we call them inks. Okay. That is what we will discuss. Till that, have fun. See you in the next session.